So thanks for that introduction. So these talks provide a great opportunity to reflect on what I'm going to share with you this morning. So why is it that so many architecturally great buildings don't perform as expected? And are there some common threads where we think significant change is needed? After 25 years in and around this industry, I believe that building control systems often contribute to poor building performance, particularly in respect to wasted energy and the impact on occupant well-being. So we've had automated controls for a long time, and I thought I'd start by going back to the beginning, through to where we are now, and on to propose a radical change to the way that we deliver these systems. So the first recorded feedback devices dated back to the Greeks 300 BC. And the first real record of automated control is often attributed to Cornelis Drebbel. He invented a chicken incubator in the 1600s, which had a mercury thermostat that automatically kept it at a constant temperature. He also designed a solar energy system for London, and apparently he built a submarine as well. In 1868, the engineer James Clerk Maxwell wrote a paper called On Governors, which considered feedback, stability and damping. And this is the first theoretical and mathematical analysis of a control system. The governors typically regulate a mechanical device, like the speed of an engine, or back in Maxwell's day, the amount of steam into the cylinder of a steam engine. In the 1800s, control systems developed for large ships and propulsion systems. And in 1911, Elmer Sperry came up with the first theory-based control system for a ship's steering. Sperry had observed that when you turned the ship's rudder, it often didn't get to where you expected. It overshot or ended up somewhere else. It needed continuous adjustment, and you had to factor in other errors, like inertia, wind and waves. And interestingly, Sperry's also famed for inventing the gyroscopic compass, airplane stabilisers and high-intensity arc lamps. 11 years later, in 1922, Nicholas Minorski developed an algorithm around these theories, again for ships. This theory is known as PID Control, which stands for Proportional, Integral and Derivative. Proportional describes the difference between the target position and the real position. Sperry found that proportional control alone didn't mean that you always met your target. So if a ship's rudder is set to a fixed or proportional position, then often it might miss or pass the target. So this integral and derivative are needed to correct this. In simple terms, integral and derivative consider past and predicted future errors and the rate of change. These were all things which Minorski had observed whilst watching the helmsman of a ship when he was developing steering systems for the US Navy. Think of this as a waveform where these corrections all come together to give the quickest and smoothest result. By doing this, PID acts to stabilise control and avoids oscillation. The development of these theories and our application is the foundation of all control that we see in building control systems today. So by example, you can think of a temperature sensor controlling a valve. So back to the timeline. These theories evolved through the 20s and 30s as controls and instrumentation companies sprung up across industry. The first digital control systems emerged in the 1960s. This is termed as direct digital control, or DDC. And the first DDC system actually went live in 1962, controlling a soda ash plant in Lancashire. And this was controlled by a computer called the Argus 500. Computers and electronics drove advances in DDC control in the 60s and 70s, DDC becoming commonplace in the 1980s, along with the term building management system. BMS manufacturers developed their own bespoke hardware and software, their business model being to sell the products and associated maintenance contract. This thinking has not really evolved much since the 1980s. There's been development in communication standards for BMS and between BMS and other systems. But really, none of the talk around open communication, or open systems as they're often termed, has changed things very much. In the late 90s, we saw a lot of talk around BMS communicating with other systems like lighting and security. The theory was good, and a few projects have been delivered, but there's not much real evidence of benefit from these integrated systems, many of them being hampered by contractual issues during construction, everyone blaming everybody else when systems didn't work or meet expectations. Of the few examples where this level of integration and communication between systems was successful, the Singleton campus at Swansea University stands out for me. Here, numerous systems talking different communications languages were connected to the university's IT network, and they were brought together to a central operator station. This worked at Swansea because they had a very specific need to be able to see and manage BMS, fire and lighting systems across 40 buildings. These systems had previously been all but invisible to the maintenance team, as there was no user interface in most of the buildings. The integration of the systems made visualisation and management of the estate far easier. The estates team no longer needing to walk around 90+ plant rooms on a weekly basis. So this generated both a time and a cost saving for them. Right now, the buzz is around smart buildings, the Internet of Things and big data. And we're certainly seeing some new solutions emerging in these areas. There is a worthwhile discussion about how these things will change the way in which buildings are controlled, and I'll touch upon that again later. For me, these advances may not get to the heart of why many building management systems, and therefore the buildings which they control, do not work well. We know that data and communication can help to identify a problem, but often the correct solution can only come with knowledge of the building, the mechanical and electrical services, and the occupants. Only then will we be sure that a building is capable of delivering the change which is needed to meet the desired performance objectives. So if we consider the 500 years of development I've described, and having personally spent 25+ years in this industry, all this intelligence leads me to ask, why do so many great buildings not work? I would suggest that around 90% of operational buildings that I visited will likely have some problems with the BMS which impacts either their energy use, the occupant, or both. Typical examples of this will be plant overridden or operating in hand, and critical control sensors failed or out of calibration. The result can be a system that runs for extended hours or out of control, wasting energy, making occupants uncomfortable, and reducing the life of building services. All this ultimately costs you, the client, money. So when I get asked what I think about this, I can only say it really does piss me off that despite the huge amount of effort we all put into the design and installation of these systems, they still so often fail to deliver a building which meets our expectations. And so I have to ask myself, why is this such a challenge to our industry? And why are we still not getting this right? Well, there's always been some smoke and mirrors involved when it comes to BMS. It's made up of sensors and actuators connected to a programmable controller. We're told that BMS complies with an open communication language, and we assume this gives us the flexibility we need when we're procuring, engineering or upgrading the system, or when we're appointing a maintenance contractor. Unfortunately, I don't think this is quite true. This is what the controls industry would like us to believe. Systems are still designed in such a way as to lock us in. It's just that the lock-in is now embedded further down in the BMS controller, at a software level where you can't see or access it beyond the open communication standard. This means when you have a problem or want to change the way something is controlled, then you generally have to return back to the installer or product manufacturer for a solution. To try and explain this, you have to understand that in a BMS system, control essentially happens at two levels. We can think of this as what happens above and below the line. Above the line, communication takes place across a network, which these days is normally an Ethernet network. Information is exchanged between controllers in an open language, which is referred to as a protocol. There are several standardised languages or protocols around. If the controls in a building use the same language or protocol, then they can talk to each other and share basic information. But if they don't follow the same protocol, then they may not talk to each other, or data exchange might be quite limited. But below the line, and crucially, control of the mechanical services does not follow this open communication standard. There's a written piece of code in the controller defined, which is called a software strategy, which determines the sequence of operation of the mechanical plant. And this complex piece of code generally remains closed to access without the necessary tools from the product manufacturer. This means the operational strategy for the plant cannot be reviewed, changed or corrected by you. Added to which, the strategy is often written to include fundamental data and settings, thereby increasing the lock-in. This means that the real system controlling the building service is essentially still closed protocol. So where does this bring me today? Well, I think a fundamental change is needed, and I would encourage everyone in this room to now consider what that might be and how together we could influence this. I'm going to tell you my thoughts and challenge the way we design and deliver building control systems. It is true that BMS can be complex even for a seemingly simple building, and it's incredibly difficult just to even describe all of this open and closed protocol communication without it sounding complex. From brief through design, construction and handover, the sequence of plant operation can often be interpreted, redeveloped and rewritten numerous times by different people. The contractor's version of the operation might be completely different to the designer's intent, and the software and commissioning engineer's version is different again. It's not uncommon that this piece of software will be rewritten many times before handover, each engineer having a preferred style or approach. And often there's a final software rewrite by a commissioning engineer on site. It's important to understand that through all these iterations, design intent is lost. There are other factors which also impact this process, such as declining skills and training in the controls industry, insufficient time for proper commissioning, and that's particularly for specialist systems, whose commissioning is often compressed at the end of a project programme, poor handover process, and lack of record information. So not surprisingly, the design gets lost in all this translation. The outcome is a shiny new building handed to an FM manager who has no idea how it works. If we take a step back now, holding on to basic theories like those developed by Sperry and Minorski, and we had a clean sheet of paper from design through delivery and maintenance of a BMS, then what could that look like and what would we do differently? Well, the journey I'm going to propose is a radical overhaul, and one which could certainly be described as death of the controls industry. We have to consider two aspects: the technology, the BMS controls themselves, and we also need to tackle the approach by which control systems are designed and delivered. And changing both will make the difference that we need. So what would I do differently if I were king of the controls industry? Well, let's think about the technology first. We need a system where all the software is truly accessible, one that's really open, that any programmer can access using a standard programming language, where we can share development of solutions and applications across the industry. And there are products like this available right now that are truly open and can deliver all of this. This approach is referred to as open source. Now, this isn't like the communication standards we've had for years, but it's a step further, where the controller is actually programmed in a common and accessible language. The simplest explanation of open source is a software solution that can be viewed, modified or enhanced by anyone. So effectively, its base code is accessible to the public. As with most software, this is still a license, but it's different in that it promotes collaboration by requiring users to share modifications or new versions with others at no cost. The key advantages to open source are that it gives people control over their software. So here, it will give you control over your BMS software. Programs and solutions can be shared across business networks and industry. Because it's open, errors and omissions can be more easily spotted and dealt with by everybody. And open source provides us greater opportunity to link control with other devices, data and information. So earlier I said I'd come back to the Internet of Things and data. At the moment, BMS is made up of controllers with hundreds or even thousands of inputs and outputs, wired to non-intelligent devices in the building such as temperature sensors and valve actuators. The Internet of Things is moving us towards new solutions, where devices such as temperature sensors are becoming intelligent, so their data can be collected without the need for a controller with all these inputs and outputs. This leads to wider availability of data which can more easily be shared and used to improve existing controls or inform new solutions. Although the controls industry is yet to wake up to this and BIM, it is possible to see the vision of a system in the not too distant future which combines all of this information, technology and real-time data into a single solution with open source at its heart. Currently, BMS manufacturers would prefer to sell you a closed system where every input and output on a BMS controller generates income and every project demands their maintenance contract. But you will find a growing number of innovative second-tier control specialists who are working in this new space. So to summarise my technical solution, be brave and ask for something truly open that provides you with access and choice. Industry needs a radical overhaul to the way we deliver these systems. Now, with open source to hand, we can rethink the design and engineering process so you get what you ask for. And for me, that fundamentally means we have to reduce the opportunity for misinterpretation and error by reducing the number of people involved. Open source enables this because we can go straight to a software solution. The designer can take the developer's brief and write an open source code which forms the basis of the final control strategy. The operational software will now be 90% complete, tested and documented at the early stage of system design. The contractor's remit then becomes supply and installation of hardware, with final installation of software and setting to work being a collaborative effort. By doing this, we will substantially reduce the potential for misinterpretation. We'll have functional, proven software before it goes to site. We'll likely reduce the commissioning and handover time. We'll have good record information early in the project, and crucially, the long-term lock-in to a BMS supplier will disappear. Working this way means we can set operational and performance objectives for the building early and ensure that the BMS meets these expectations. So to conclude, I'm advocating a revolution. There might be some challenges to overcome, as there are with any new solution, but the benefits will be worth it, and we will see a significant step forward for building owners, operators and users. We have to get to a point where we're in control of our controls. So be brave. Think beyond the aesthetic beauty of a building and consider what is needed to make it perform now and in the future, and insist on this change. In the words of LBJ, yesterday is not ours to recover, but tomorrow is ours to win. Thank you. So, any questions?
I thought your point about the designers taking responsibility for delivering the software element is really interesting. And that would be quite a change from the existing approach where the software and the hardware is linked together. How do you think the existing controls industry will respond to that particular part of your proposition?
I would hope they'll receive it well. I mean, their remit then becomes supply and installation of hardware. So in effect, their delivery actually becomes a little bit easier than it is. And as you say, we would be taking responsibility ourselves, not only for the design, but actually seeing it all the way through to conclusion. So I think it provides benefit to everybody.
So, quick question about the early on in the design concept, actually bringing a controls solution that's vetted and is complete.
Yeah.
That's a significant change to obviously what the current climate is. Quite often we don't know a control system elements until way later.
Yeah.
How do you think that will be achieved? Obviously that will bring a lot of the design detail closer to the concept stage.
Yeah. I think for us as Arup, certainly, we at the moment we put together quite a detailed design for a control system anyway, in terms of the description of operation. So what I'm proposing here is a move away from spending all of that time just writing the description of operation to actually put in the final strategy together. So that, for me, is the main change. And the whole point of this is to get over all of that loss in translation as it goes through all the contract stages, and all of these different people become involved with writing the software and interpreting that design. I mean, I can think of projects where we get the contractor's just written version of that description of operation that looks completely different from where we started off, and we go over and over those iterations, and then the same thing happens with the software.
A lot of time spent wasted.
It's huge. And then potentially it gets to site and you've got a commissioning guy who likes to write software in a completely different way, and he just throws that lot away and does something else. So yeah, it's really trying to get over that and past that. So we've got that design cemented as early as possible.
How do you see buy-in with the FM team and making sure they're adequately trained for this and giving them more flexibility? Do you see that as a bigger risk?
No, I don't think I see it as a risk. Obviously, there'll still be some training involved. If they're going to have to learn an open source code or something like that. But the point is that these things are publicly available codes and methods of programming. So no, I don't see it as too much of a barrier. I mean, they're not going to have to go off and go to a manufacturer and go through their training and become certified for that specific piece of equipment anymore. So I think that's a step forwards.
Because some of the biggest problems I've seen is when the FM team have had a tweak with the BMS system and it's not operating as it should because of their input.
Yeah.
So how do you see this working with that?
But that's maybe because they can't get far enough into the BMS and actually see and understand what's going on with it. So by going this open source route and opening all of this code up, then they should be able to see and understand and interpret it themselves. I think, you know, because there's this this level of lockdown where the code is essentially hidden and all the FM guys got to go on is, you know, a description of operation from somebody, whether it was the consultant or the contractor. They might not actually even know what they're changing. I mean, my experience is that the FM guys on site generally firefight. If somebody comes and complains about something, then, you know, stuff gets overridden or set points get moved to the extreme. So they're not necessarily taking the right action to solve the problem. But by having more accessibility and being able to actually get into the code and see it and understand it, hopefully that will help the situation.
On that subject, sorry to jump in. On that subject, what about bringing the FM team or procuring an FM team to bring it into the process a lot earlier?
Yeah, why not? Yeah, get them to the table when we're putting the thing together. Yeah.
I think that buying the FM team and bringing them into the design, if you know who the FM team are at the time, would be a massive tick in the box.
I mean, I think it kind of links back to that kind of soft landings approach, that the more people that you can get involved early that are ultimately going to, you know, manage, occupy, run the building, then the greater the chance you've got of finding a solution that's going to work for everybody.
Darren, you mentioned the compression of the commissioning programme and that the contractors will be installing hardware. How significant do you think that is to the unsatisfactory BMS operations, incomplete install, faults that never get corrected?
How significant is it now?
Yes, because while we correct the software, you can make that better.
Yeah.
You still need all the hardware, the install to be complete and set to work.
Yeah.
Ideally prior to PC. You know,
Yeah.
Is there any way of turning that around?
Of course, there's still going to be commissioning of hardware and point-to-point checks on site to make sure you know this point is talking to that point before the software goes into the system. I think having this approach where things are engineered and tested off-site early is going to help, because my personal view is that it's not the point-to-point commissioning that takes the time. It's the going round and round and actually finding, why is that thing not under control? Why is it not in the position it should be, or achieving the temperature in the duct that it should be? So, yeah, I think the Internet of Things and having that intelligence actually coming up into the devices and the sensors will potentially help as well, because at the moment the point-to-point is from the operator station through the controller and then to the end device, and by going forward with the technology more into the directly connected things in that internet kind of network, we're taking a link out of the chain that we're not having to pre-commission. So I think as time goes on and we see more of those kinds of devices and that kind of automation, that is going to help the situation.
How do you see this change happening? Do you think this is something which will be pushed by clients or pushed by legislation saying it must be open source, or by sort of a design ethos change?
I think it needs to be pushed by clients and the people in this room to say, yeah, this is a good idea, and we want our control systems procured and engineered in a different way, so that we get something that works.
Just to go on from that point earlier, one of the main issues is there's so much package plant now that comes with its own controls on board, yet we're putting controls on top of them controls which are unable to communicate effectively with them controls in the package system. So we end up commissioning all over again, or dumbing down the effectiveness of what's already there. If we run with the whole concept of an open system that can communicate effectively with package systems, then them systems come to site ready to run. Yet we're introducing issues and errors by overlaying things on top of them that prevent them from functioning as they were intended.
Yeah.
Just going on from that, if we see a future where the hardware, we're a little bit more agnostic towards the hardware, we don't really care what it is, do you see a refocusing of controls engineering businesses on the business of engineering, rather than being locked into the business of the supply of the controller and the engineering? Because in the old days, before trends say, there were boxes, and controls and instrumentation engineers were focused on controls and instrumentation.
Yeah.
And in a way, would you see a refocus back to that area of more specialist engineering?
Yeah, I would certainly hope so. I mean, as I said in the presentation, and I think you've alluded to, the model at the moment for most controls contractors is selling hardware and boxes and the maintenance contract that goes behind it. And we kind of know that's big business. And then something gets lost in the engineering itself and finding the right solution for the building. So, yeah, I would hope that by going this route, we refocus and we go back to that.
I agree with everything that's been said, and you get the same thing with lighting systems where you get generic hardware that you have a specialist software house write the program to run it, so it's the same thing. But don't you think that like Vizria and BREEAM should be more involved in directing the way that we install these systems? And is there any pressure being put on them to enlighten them perhaps to take it on board to have an open protocol type system?
That's a very good question. I don't think there is at the moment. It's certainly something that we should go and talk to them about. You know, certainly some of those things are looking at in use of a building, you know, whether that actually works and how that contributes to energy consumption and occupant comfort and all of those things. And you know, even from some of the occupant surveys we do, we see that people would like more control than they actually get and a better form of user interface. But yeah, I don't think it's come up to that level yet where those standards are specifically saying it should be open protocol or open source.
Yeah, they do drive the standard of maintaining the systems, and they recognise the importance of it.
Yeah.
But I don't think perhaps they've got fully behind this, which is, you know, truly the way it should be going, and should every other part of property and building systems controls, whether it's BMS, whether it's
they should all follow. They should all follow this format.
It should all be open source.
Open source, yeah.
Agree.
As a client, we always have problems with the BMS system, because it always causes a problem in a new building. But if we have the same problem with lifts, funny enough, but we don't have the accessibility to the main system. But if we make the system more open, will we just be putting that power into or that control into the hands of the commissioning engineer, because he'll be able to set it up to his own personal whims? Effectively, we'll lose control that way, or we're just moving the blockage.
Not necessarily the commissioning engineer, because the solution that I'm proposing is that we're there alongside the contractor and the commissioning engineer as the project's delivered. You could perhaps argue that when it gets into the hands of the maintenance contractor, if it's more open and they've got more access and they can do more with it, is there a risk there that they're going to mess something up? Yeah, I mean, there's a risk there, but at the moment the problem is that they can't access it and they can't do anything at all with it. You know, they can't see the code, they don't understand the sequence of operation, so they're not doing the best by the control system or the building. So I would hope that by opening it up this way, we're creating more opportunity for those guys to get skilled up and understand the system and operate it properly.
Is there an argument here, though, that the trust you put into the system manufacturer perhaps have let us down by making it closed? We're just now putting that trust in the hands of the FM guy.
Well, you are putting trust in the hands of the FM guy, but because it's more open, there's more opportunity for other people to get involved.
Will there be a backtrack the changes that have been made and look into the running procedures that the FM engineer may have installed?
Sure, I mean, as with any system, you know, you can create something that tells you the history of who's accessed the systems and who's made what changes to them. So yeah, I would, you know, that's within BMS at the moment, and I would expect that to carry on.
Just to pick up quickly, I think one of the issues though is that with the intent of delivering an effective and efficient building, that goal is a great goal, but the blurring of achieving that goal in part, and it is blurred by the controls companies who are locking things down for the purposes of making money. So if you can remove that barrier by making things more open, it does attract more opportunity to achieve the aspirations of making the building work properly, because then that is the engineers do want that to happen. I think we all agree with that.
I entirely agree with that.
Yeah.
And the problem they cause, the only issue I've got is, are you removing the barrier, just moving it along the supply chain? That's my concern. If there is a bad problem there, it means fixing. And
If it's tied with continuous commissioning, you may end up improving the system anyway and deliberately changing things because it doesn't quite work. So it's a double-edged sword.
Yeah. Yeah, you make a good point. I mean, continuous commissioning, you know, you should be going back and keeping a check on the way that these things are operating and making sure that the building's continuing to perform.
There was a slide back there where you said, why do so many great works of architecture have poor controls? I was wondering, are you thinking that there's something specific to really good architecture that really good I'm just curious from an architect's point of view, because or were you just saying it's great so the control should also...
It wasn't a dig at architects, don't worry.
But do you think that, so you don't think that there's something that when architecture gets more foregrounded that then controls start to fall?
No, I think it applies to all buildings. It's just that maybe when you look at some architecturally great buildings, perhaps it gets overlooked a little bit more in terms of the systems and the way it's controlled. You know, the architecture is perhaps brought to the fore, if you like, over those systems that are actually operating in the background.
I think one of the things for architects is that because we get these fixed boxes that we can't control, you get something you design every single detail, and then you get this plastic, white, rounded box that nobody can actually get into and change. So I think what you're suggesting is a big opportunity for designers, because if suddenly we have an opportunity to engineer or to design or detail all the control systems on the front end when you're doing your interiors, I think that would make a really big difference.
Yeah. Okay. Thank you.
Yeah, I think Darren's design and change of the way the industry is going and his thoughts on it are very interesting. We've already got a partial stage there, as I was talking to my colleague earlier, about managed protocol systems, which are a good step in that direction. But what Darren's advocating is, in my view, a much better way forward, as long as we can get everybody on board. The Crown Estate, our client, is a fervent advocator of development for sustainable and energy-saving buildings, and works very closely with BREEAM and BISRIA in order to achieve that. So using open protocol systems will, in my view, enable us to continue to develop the system to a point where the properties run as they should.
I think it's a great step forward in terms of new thinking. What I would say is I think it will take us forward, but we really need to get to the end user and make sure that the people that are using the systems really do understand the design premise that they're working under. I think, in my experience, I find that it's always the end user that tends to mess things up. But actually getting a better product in the first instance, open source is definitely the way to go.
Well, Darren also described how projects should be delivered accurately. So detailed design, factory testing, change control, and that's doing it properly. And it's a good example is where we're involved on the Shard of Glass, delivering for seller, and that worked very well. And that was an open protocol with using a backnet solution. Where Darren's talking about using an open solution so that each controller in each item of plant is programmed exactly the same way, I agree with. Whether that change is likely to happen in the next couple of years, I don't think so. It's a nice idea, and I think it should be pushed that way, but when you look at major manufacturers who cannot change their product even though they own product manufacturers within their group, I think they're facing a real challenge to do that.
I think it was quite interesting. As an architect, one of the things I find sort of on the MEP side of things, it's a bit of a dark art, especially BMS. So understanding how building controls work and understanding the limitations as well, I found it took me back a little bit. I was under the impression there was a bit more control, a bit more finesse within there. But it's quite interesting to see the industry sort of understand these problems and propose solutions and come up with new ideas and innovative thoughts on them. It's very interesting.
Well, I think for architects, it's actually a very, very important thing because for me, for instance, as an architect, I'm really interested in finding out how I can use innovative design to improve human well-being. So obviously controls are critical to that story, but because we have so little control over the controls, it gives us lots of problems when it comes to design. So I think his idea about using open source might allow us to actually start influencing the individual pieces of equipment that we specify and really understanding how our users will use our buildings and not just look at our buildings. So that could take us to the next level, I think, when it comes to design.